This session will be presenting the results of the Prometheus project, which was carried out at the University of Exeter, and it's about a new data set for weather files related to climate change. I'd like to introduce Dr. Tristan Kershaw. He's the physicist behind this from the University of Exeter. I'm Richard Quincey from IES. We're one of the partners on the project, and I need to acknowledge, oh, it's up there, sorry, the other partners on the project. The project was funded by the EPSRC and also supported by a number of other major organisations, including CIBSE, REBA, the Met Office and so on. Before Dr. Kershaw talks about the science behind this project, we thought it would be a good idea to put the weather data into some context for you. Now, most people here probably are aware of weather data produced by CIBSE that's used in, for example, the building regulations at the moment. However, it's clear that nobody at the moment, whether it be voluntary or mandatory, is actually asking people to test their buildings or their building designs against future climate change. And if you don't do this, you run the risk potentially of buildings failing to last in the long term, and thus there is this risk that they will not be as sustainable as you think. The other issue about this, I think, is for building owners, in that actually carrying out this sort of analysis is really a risk assessment against your investment. So the Prometheus project is about providing the best science behind weather data that we can at this point in time, and this session is looking at that data and also the consequences for you as designers.
Which files should you be using? The UK Climate Impacts Programme would say that you have to run thousands. I say that you could do that with just 5. Generally, if you push for time, as most building modelers are, you could run 1. It's not ideal, but at least it would give you an answer. But things to consider are, what is the building you're building? If it's a hospital or a care home where you have a duty of care for the occupants, you have to consider the risk, especially if they're vulnerable groups. So then you maybe want to look at the whole range of impacts, specifically the higher emission scenarios and the higher probability levels. You can carry out cost-benefit analysis. You can consider adaptation options and how much they cost and when you could need to apply those. You need to talk to your client. What do they want? What do they need? So, I'm currently involved in a few technology strategy board projects as well, specifically adapting buildings to climate change. So this is one of the council offices down in Cornwall, and they've come to us and said, we're refurbishing this office, we want to stick twice as many people in it. We also want to create a modern working environment, and we want to avoid any overheating in the future. It's quite a heady list of demands, really, perhaps slightly unrealistic. But what we are able to do for is we are able to create weather files, model their building, and come up with a list of possible adaptation options, and they can then choose from those which they feel meet their demands best. They're interested in primarily overheating, thermal comfort, productivity of their workers. Their energy bills are tiny compared to how much they spend on paying their employees. They want to get every bit of work out there that they can. And there is direct evidence between temperature and productivity, and that's what they're quite interested in.
Earlier we suggested that perhaps a building might last a very long time if you're going to consider it to be properly sustainable. I mean, that might be 100 years. It's probably around that amount to be really sustainable, I suspect. But you need to be, with this data, aware that, of course, there's different life cycles of buildings. The building fabric, fair enough, about 100 years or so. or more if you're lucky. But also HVAC equipment is usually replaced about every 20-25 years. So when you're looking at these risk assessments on buildings, you need to be bearing in mind that you get the building right first, because it's got to last the longest time. It's got to be able to deal with, for example, an increase in HVAC system size over a long period of time. So, for example, your voids in the ceilings, you need to think about it, because if you can't put in the HVAC system, the building's basically useless after a certain period of time. You also need to think about things like the HVAC plant, because in that 20-year period, of course, you've got to be able to deal with that small change in the climate, but also how you actually adapt it in the future. I mean, do you actually increase things like your shading as time goes on to reduce your solar gains? Do you even, for example, change your HVAC strategy? The other thing I would suggest to you, toward the end of this period, you're probably also going to be looking at comfort. It's going to have to change, because the way energy prices are going, I suspect the comfort zone is probably going to expand. To conclude on this stuff, I mean, all this work from Prometheus was funded by the EPSRC, and the data is available for free on the web. You can just download it. You can either Google Prometheus and University Exeter and you'll find the website directly, or you can go through our website where there's a link directly to the same website. But you can download it, and I suspect most simulation software packages that people use will be able to use this data. Ours does, obviously. It's the intent of the Prometheus project was obviously to produce a set of weather data that's based on the latest science. So hopefully, and Tristan, you might want to say more about this, that there's a higher level of confidence with this data. However, the question I asked Tristan as a practicing engineer was, which data set do I use? And I think the answer is a bit uncomfortable for engineers, well, you have to use all of them. So you might actually run 5 simulations for each period of time in the future, and you have a range result, and you're going to have to look at it as a risk analysis. Now that's a very different thing to in the past. I mean, I can remember when I was a young engineer, all we had was, say, -4 degrees C and 28 degrees C, and that's what you designed to. Now we're talking about looking at current day, 2020, 2050 and 2080, and you run about 5 weather sets in each, and then you look at it as a risk assessment. That's quite significant, but I think nowadays the way we do compliance, which is basically through simulation software, it's actually not that much an overhead if you can just run it with the models that you already have. And then I think you've got to make decisions as to how well the building design can actually adapt over time to the predicted conditions for that particular location. I think if we don't do this, we are at a great risk of producing buildings that may actually be viewed at the time of design as being very sustainable, but actually in reality might turn out to have quite a short lifespan.